Well, hi, welcome back as we continue the discussion on our challenge problem here, problem number 9. We did parts A and B in the previous video, which looked a little bit weird because we had that n in the answer. We had that variable in there. But if we look at part C, now they're giving us a value for n, so whew, can relax a little bit. I don't have to worry about variables running around. I'm going to have something to plug in. So let's see what C is actually asking us for. So if we remember, we've got a total of n marbles. 2 of them are blue. We've got our friend Haley here playing a game where she randomly draws marbles out of the bag, one at a time, without replacing. And the game ends when she draws a blue marble. So everything stops once we get a blue marble. All right, so let's look at part C. Part C. So let n be equal to 5. Yes, all right, I have a number to work with. I've got 5 marbles in the bag. So now I can draw a little bag or something that vaguely resembles a bag. And I've got 5 marbles, so I've got 1, 2 blue marbles. Yeah, it kind of looks like a face, a little hairdo up there or something. Anyways, 1, 2, and 3, 4, 5. So I've got 5 total marbles. 2 of them are blue. They're all in our bag. Find the probability that the game will end on her 3rd throw. Okay, so the previous problems, we set up tree diagrams for 2 throws. Now I've got a 3rd throw to think about. All right, so I'm going to use tree diagrams to organize this. There are different ways that you can think about this. It turns out you don't have to do tree diagrams. You can think of this, if you're good with probability, if I want to know the probability of blue on the 3rd draw, well, what does that mean has to happen? Well, what that actually means is, if the blue has to come on the 3rd draw, what has to happen on the 1st draw? What color does she have to draw? Well, she can't draw blue, otherwise the game's over, which means she has to draw not blue. And what has to happen on the 2nd draw? Remember, it ends if she pulls a blue, so if we want 3 times, that 2nd draw also has to be not blue. And if we want this to win on the 3rd draw, we can draw a blue. So if I want to draw blue on the 3rd, this means not blue, and finally a blue. Okay, well, let's think about this. And actually, I might draw a tree diagram in a little bit, but we really don't need it. What's the probability that Haley draws not blue? Well, how many marbles are in the bag? There are 5. And how many of them are not blue? 3. So there are 3 not blue marbles. There are 5 total marbles. And means multiply. Now I need another not blue, but remember, this is all without replacement. So when she pulls a not blue marble out of the bag, she sets it aside, which means one of our not blue marbles is gone. So now, how many not blue marbles are there? Well, now there are 2 not blue marbles, and how many marbles total? There are 4. And we've already seen that means multiply. Now I need blue. Well, again, she pulled another not blue marble out of the bag, and she sets it aside, so now we need a blue marble. How many blue marbles are there? There are now 2 blue marbles, and how many marbles total? There are 3. So notice my denominator goes down by 1 each time, because each time we're pulling a marble out of the bag. And my numerator is going to depend on whether I have a not blue marble or a blue marble. Okay, so let's see. If I multiply all this across, I should get 18 on the top there, right? Just kidding, 12. How did I get 18 on the top? Oh, I have 2 3s. Never mind. Just kidding. I'm going to get 12 on the top. I'm going to have 3 times 2 is 6. 6 times 2 is 12. I'm going to have 5 times 4 is 20. 20 times 3, last I checked, gives me 60. Sometimes I change that on me, but last I knew that was 60. So 12 out of 60 is a perfectly acceptable response. If you want to reduce that to 1/5, that is also a perfectly acceptable response. If you want to make that 0.2, that is also an acceptable response. I will just really quick, if you like tree diagrams and you want to see what this looks like on a tree diagram, because I have 3 draws, it's going to be a little bit more elaborate. But this is what we might get. I'm going to have, on my first draw, we can draw blue or not blue. Okay, probability of drawing blue is going to be 2 out of 5. Not blue is going to be 3 out of 5. Now for the second draw, she can again draw blue, or she can draw not blue. Looks like my black pen is running out here. I wonder if I have another one. Not this kind. Let's see if we can make it last. Now, because we already drew blue, there's 1 fewer blue. There's also 1 fewer marbles total. There are still 3 not blues, but now there's 4 marbles total because I took 1 out. For this one, I still have my original 2 blue, and I have 4 total. And now I have 2 not blue and 4 total. So this was for my first draw. This one is for my second draw. Well, now I've got a third draw. All right, now we got to be a little bit careful here. If she draws 2 blue marbles, is there any way that she can draw a blue marble again? Like, we already drew a blue marble. That's going to be 0 out of 3, which means getting not blue is going to be 3 out of 3. Black pen. And so for this one, again, I could have a blue and I could have a not blue. My blue, let's see, I've still got 2 blues in there, right? Because I haven't drawn a blue yet. So this is going to be 2 out of 3. Can I do that right? No, just kidding, because we drew a blue here. Sorry, this is going to be 1 blue. 1 blue out of 3. And this is going to be 2 not blues out of 3. And we can do the same down here. I'm actually not going to continue to do this. I think doing the work up here is a little bit easier, and my black pen is running out. But you would do the same idea with these next 2. So if you really want to use a tree diagram, you can. I think thinking of it more logically works a little bit better, though. So there you go. Part C for our challenge problem number 9.